Homework 15 is about condensing logarithms, making them simplifying them, which is something that we learned about obviously in the original videos, in the original practice materials. There are a series of rules by which you can condense logarithms, so if you haven't already done so, obviously you should go over those. But in this case, we could make things a lot simpler, and for number one, remember that subtracting a logarithm is the same thing as putting the two terms over here on dividing. Subtracting an entire logarithm is the same thing as dividing the expressions that are subject to the logarithm. So log base 2 96 minus log base 2 3 is the same thing as log base 2 of 96 over 3. Now here, of course, you can simplify it a little bit because we know 96 divided by 3, and 96 divided by 3 is 32. So really this is the same thing as saying log base 2 of 32. Now here we can actually figure out what that is, because this means 2 to a certain power, whatever that power is, equals 32. 2 to the x equals 32, and x actually is 5 because 2 to the 5th power happens to be 32. Not always going to be able to simplify it. In fact, on this page, I think it's the only one that you can actually simplify like that, but you can do it in this case. Number two is we've got a log, and again, if there's no base, the presumption is that it's a base 10. So same rule. Subtracting is the same thing as dividing what is being subject to a log. So this is the same thing as log with no base, which means base 10. Of 2x plus 5 divided by x. Now, I don't see that there is any real way to simplify this anymore, so we can just leave it like that. You know, sometimes you're going to have problems where you can simplify it in multiple steps. Here, I don't really see that as being applicable. Okay, now this one, number 3, is something that we can do in terms of both steps. And that is, we've got a multiply of a logarithmic term is the same thing as putting whatever the coefficient is as the exponent of the term inside. So this is really the same thing. If we leave log x for a second, this is really the same thing as log y to the 3rd power. Now we can combine them, because two expressions of logarithms being added to each other is the same thing as the expressions multiplying. So this is the same thing as log of x times y to the 3rd. Again, you can see it's definitely a slightly more simplified expression than the original one. Number 4 is actually very similar. Here we have a 1/2, and we could make this x to the 1/2, and of course x to the 1/2 is the same thing as a square root, as we discussed a little while ago in the previous homework. So this is really the same thing as ln. ln, of course, means natural log, which is a log with a base of e. So natural log x to the 1/2 power, which is the same thing as the square root of x, plus ln of y, is the same thing as ln square root of x times y. Remember, the y is not inside the square root, because the term is being multiplied by y, but this is the simplest that you can apply it to. And the next one is really the same idea. Again, we can multiply. This time we actually have 2 times the loggers being multiplied, so we can put the 2 over here, and we could put the 3 over here, which means log base b. Again, they're both base b in this case. If they're different bases, you can't combine them at all. But we've got an x squared plus 3, or we can make this log base b, and we moved the 3 to the exponent of y, and then we could simplify it one more time by saying log base b x to the 2nd times y to the 3rd. Again, really the same idea that we did before, except we had 2 exponents here that we were able to simplify. Numbers 6 and 7 are virtually identical to the ones that we've looked at so far, so let's do them relatively quickly. We've got a 4, which we can make as the power to the x plus 6, and a 3 that we can make as the power to the x. Again, we're talking about natural logs, so we can combine them. So we've got ln of x plus 6 to the 4th power minus 3, or minus ln of x to the third power. And then to combine them, since it's subtracting, we can divide them. ln of x plus 6 to the fourth power divided by x to the third power. And I don't see any way to really combine it. Maybe you could multiply this out, and probably not. You'd have to do x squared plus 12x plus, well, you'd have to, it would be, I think you can just leave it like this. It's fine. All right, so number 7 is the same thing. We've got 3 terms, but the principles are the exact same. They're all natural logs. 3 ln x is the same thing as ln x to the third, plus 5 ln y is the same thing as ln y to the fifth, minus 6 ln z to the sixth. And then you can multiply the top two and then divide it by the bottom. So we could make this into one big natural log with x to the third times y to the fifth on top, and then divide by z to the sixth. See, because this was an addition, so we multiplied, and then we subtracted, so therefore you can divide that. And they're all under one big natural logarithm. Okay, the last part is solving equations by getting the same base. So let's just say, without even looking at this, let's say I said, for example, I told you that x to the second equals x to the y minus 1, something to that effect. And I asked you, what's y? Well, since the bases are the same, the exponents must be the same as well, because the whole expression is equal. So then that would mean that 2 equals y minus 1. And then you'd add 1 to each side, and you get y equals 3. So y has to be 3. I mean, it's common sense that y has to be 3. Same thing is true, for example, if I say 7 to the x plus 2 equals 7 to the 10th, well, then they have the same base, so x plus 2 has to equal 10. So x is 8. Problem is, first you have to get it to the same base, otherwise you can't do this. Well, let's see by number 8. Number 8, neither of these are in and of themselves the same. Obviously, they're not the same base, and it's not that easy to get the 625 into the 125 base, but you can reduce them both. If you recognize them, you can reduce them both to a 5 base, because 125 is 5 to the third power, and 625 is 5 to the fourth power. So this is the same thing as 5 to the third power times x, because the x is still there. So you see why it's the same thing? 5 to the third is 125. So 5 to the 3x is the same thing as 125 to the x, equals 5 to the fourth power, because that's 625. Now that they've got the same base, you can set them equal to each other, which means 3x equals 4, divide each side by 3, and you've got x equals 4/3. Second one, again, you have to set them equal to the same base. E is the base on the left side, that's fine. On the right side, can you make e the base as well? Sure. Remember what you do to get something to the denominator, like we did on the previous homework as well? You raise it to the negative 1. Just like, for example, 3 to the negative 1 was 1 over 3. So e to the negative 1 is 1 over e. So 1 over e is the same thing as e to the negative 1. Now we've got the same base. So we can drop the e's and say x plus 1 equals negative 1. Now we can subtract 1 from each side, and x equals negative 2. And finally, here, again, it's not going to be quite as easy, because 16 doesn't, you can't just put 8 to some power. 8 to the second power is going to be 64. But you can drop them both. And if you recognize them, you can realize that both are powers of 2. 8 is 2 to the third power, and 16 is 2 to the fourth power. So if we drop them both to base 2, so we have to raise this expression to the third power just to get 8. And of course, the x plus 3 doesn't go anywhere. So we're going to do 3 times x plus 3. See why that is? 2 to the third power is 8, but it was already being raised to the x plus 3. So you can say this expression is the same thing as 2 to the third times x plus 3, equals 16. We're going to drop to 2 also. Instead of putting a 3 over here, we're going to need to put a 4 over here, because 2 to the fourth power is 16. And of course, the x minus 1 stays as well. Now that we've got the same base, we can drop the 2's and set the exponents equal to each other. 3 times x plus 3 equals 4 times x minus 1. Open up the parentheses and solve like you would a very simple equation. 3x plus 9 equals 4x minus 4. Let's say subtract 4x from each side, and then subtract 9 from each side, and you've got negative x equals negative 13. Divide or multiply each side by negative 1, just make everything positive, and you've got x equals positive 13. And if you want to check it, you can check it based on this equation over here. Let's check 3 times 13 plus 3 equals 4 times 13 minus 1. Well, 13 plus 3 is 16. 13 minus 1 is 12. 3 times 16 is 48. 4 times 12 is 48. So it checks.